Hello, welcome again. We are solving some questions of uh, thermal engineering. The topic is IC engine, gas turbine and compressor. Question number 7 is an ideal air standard Otto cycle has a compression ratio of 8.5. If the ratio of specific heat of air gamma is 1.4, what is the thermal efficiency of Otto cycle? So as compression ratio is 8.5 and gamma is 1.4, so efficiency of Otto cycle is 1 minus 1 by r gamma minus 1, and gamma is 1.4, so 1 by 8.5 raised to power 0.4, so that will be 57.51%. Okay, so answer is option A. Next, for an engine operating on air standard Otto cycle, the clearance volume is 10% of swept volume. The specific heat ratio of air is 1.4. The air standard cycle efficiency is option A 38.3%, option B 39.8%, option C 60.2%, and option D 61.7%. So the clearance volume is 10%. Okay, so the compression ratio is uh, Vs by Vs plus Vc by Vc. So Vs is swept volume and Vc is clearance volume. Okay, so R is Vs plus Vc by Vc. Okay, as it is given that the clearance volume is 10% of the swept volume, so it is Vc is your 0.1 Vs, so it will be 0.1 Vs plus Vs divided by 0.1 Vs. Okay, putting the value of Vc, so it will be 1.1 by 0.1, that is 11. Okay, so the efficiency is 1 minus 1 by r gamma minus 1, or r is 11. So putting the values, we have 11 raised to power 0.4, or efficiency is 1 minus 0.3832, or 61.67%. Okay. So answer is D. Next, an engine working on air standard Otto cycle has a cylinder diameter of 10 cm and stroke length 15 cm. The ratio of specific heat for air is 1.4. If the clearance volume is 196.33 cubic centimeter, cc means cubic centimeter, and the heat supplied per kg of air per cycle is 1800 kilojoule per kg. The work output per cycle per kg of air is option A 879.1 kilojoule, option B 890.2 kilojoule, option C 895.3 kilojoule, and option D 973.5 kilojoule. Okay, so diameter of the cylinder is 10 centimeter, and length of the stroke is 15 centimeter. Abstract volume is pi by 4 d square L, or it will be 178.09 centimeter. And clearance volume is given as 196.3 cc, or cubic centimeter. Okay, so this is also in cubic centimeter or cc. So clearance volume is 196.3 centimeter cube, and total volume is Vs plus Vc. So Vs is 1178.09, Vc is 196.3. So total volume is 1374.39 centimeter cube, and the compression ratio is Vt by Vc. So 1374.39 by Vc. Okay, so compression ratio is 7. That is given. Okay, sorry, that we have found out Vt by Vc. Okay, that is R is your 7, so efficiency is your 1 minus 1 by r gamma minus 1. So putting the value of r as 7, so efficiency is 0.54. So heat supplied, as heat supplied is given as 1800 kilojoule per kilogram. So work done is heat supplied into efficiency. So heat supplied is 1800 and efficiency is 0.54, or so the work done will be 973.9, so 973.5 kilojoule per kilogram. Okay, so answer is option B. Next, the stroke and bore of a 4-stroke spark ignition engine are 250 mm and 200 mm respectively. The clearance volume is 0.001 meter cube. If the specific heat ratio gamma is equal to 1.4, the air standard efficiency of the engine is option A 46.4%, option B 56.1%, option C 58.2%, option D 62.8%. Okay, so the stroke is given as 250 mm and bore is given as 200 mm, and clearance volume is this. Okay, so the total volume is pi by 4, swept volume is pi by 4 d square l. Okay, and it will be your 7853981 mm cube. Okay, or in meter cube it is point we divide by 1000 cube. Okay, 0.00785398 meter cube. Okay, and clearance volume is given as 0.001, and clearance volume is given as 0.001 meter cube. Okay, so the total volume is summation of swept volume and clearance volume, so that is 0.0085398. Okay, and the compression ratio is total volume by clearance volume, so it will be 8.85 will be all this. Okay, and efficiency is again the same formula, 1 minus 1 by r comma minus 1. So put in the value, we can get efficiency as 58.2%. Okay, just we have to find out the swept volume and clearance volume, and then add to find out total volume, and then divide by Vc to find out clearance, to find out compression ratio, and then use 1 minus 1 by gamma. Okay, 1 minus 1 by r comma 1. Okay. Next, in an air standard auto vehicle, compression ratio is 10. The condition at the beginning of the stroke, compression stroke, is 100 kPa and 27 degrees Celsius. Heat added at constant volume is 1500 kilojoule per kilogram, while 700 kilojoule per kilogram of heat is ejected during the other constant volume process in the cycle. Specific gas constant for air is equal to 0.287 kilojoule per kilogram per degree Kelvin. The mean effective pressure in kPa of the cycle is option A 103, option B 310, option C 515, and option D 1032. Okay, so here the temperature at the beginning of the stroke is 27 degrees Celsius or 300 Kelvin, and pressure is 100 kPa, and compression ratio is 10. Okay, so the volume at the beginning of the compression stroke, Vt, can be found by using, because P is known and T is known, so we can use PV by T is equal to R. So this is the volume at the beginning of stroke, that is 0.861 meter cube, and compression ratio is Vt by Vc. Okay, and this is your Vt, and Vt is your 0.861 and divided by Vc. Vc is your compression ratio is given as 10, so Vc is your 0.0861 meter cube. Okay, so total volume is Vcs plus Vc. So total volume is Vs plus Vc, and Vt is your 0.861. So we can find out swept volume. Swept volume is the subtraction Vc from this, that is 0.7749, and heat added is given as 1500 kilojoule per kilogram, and heat ejected is given as 700 kilojoule per kilogram. So work done is heat added minus heat ejected, that is 800 kilojoule per kilogram, and mean we know that the work done is mean effective pressure into swept volume. Swept volume we have found out, so mean effective pressure will be 800 by swept volume, that is 0.7749. So 1032 kPa is the